In this video, I'm going to talk about how to use decision tree in coronavirus statistics. So what is a decision tree? A decision tree is a decision support tool that uses a tree-like model of decisions and their possible consequences, including chance event outcomes, resource costs, and utility. Let's see an example. When you file tax return, you'll need to decide if you are non-resident alien or a resident alien. So here's the decision tree. The first question is, were you a lawful permanent resident of the United States, i.e. if you have a green card? If you say yes, and then you are a resident alien. If you answer no, and then it comes to the next question. Were you physically present in the United States on at least 31 days during the current tax year? If your answer is no, and then you are non-resident alien. If you answer yes, and then we'll go to the next question, so on and so forth. Now you can see in this process we have several steps. First, you need to understand the conditions, and then you split into subsets. All those questions will lead you to the next checkpoint. After you answer the question, if you fall in certain category, say resident alien, and then you stop. Otherwise, for example, if you answer no to this question, and then you have to find out the final answer based on the next question. So if they are not pure, you have to repeat the process. In this video, by using decision tree, I try to find out if a person can survive or die based on the statistic data about coronavirus by age, by sex, by comorbidity. I got the data from this website. From this website, I got some statistics data about coronavirus fatality rate by age, by sex, by comorbidity. But unfortunately, I don't have access to the original data. So I generated some dummy data based on those statistics data with a spreadsheet. This is the Excel spreadsheet I used to generate the dummy data. First, there are 4 conditions I use here. One is age, one is sex, another one is if they have heart disease, the fourth one is if they have diabetes. And based on all those conditions, for example, if it's 1 means this person has diabetes. Based on those conditions, I will generate the final result. Say if the person will survive, which is 0, or the person will die, which is 1. You can see every time if I refresh the spreadsheet, the result will change. And I just adjust all those parameters here in order to match the statistics data I got from that website I showed you before. After I generate those data, I just copy the value to another spreadsheet. After I copy the data to another sheet, I just line up the data. You see this column is the age, and next one is sex, and next one is if they have heart disease, next one if they have diabetes, and then the last column is the result, if he will survive or die. And then I load all those data into Python. After I generated the dummy data with Excel spreadsheet, I loaded all those data into Python. First, I separate the independent variable with the dependent variable, and then I separate the data to the training set and the test set, and then I call the decision tree library in Python. After I run the decision tree, I created this PDF file. Okay, let's run Python. You can see I load the data, and then I separate independent variable from dependent variable, and then I generate the PDF file. Let's take a look at the result. Before we view our result, let me clarify one concept: Gini index. Gini index was originally designed to measure the distribution of income across income percentile in a population. If the Gini coefficient is 0, means every resident has the same income. If the Gini coefficient is 1, means one person earns all the income and everyone else earns nothing. If we draw a graph, you can see along with the cumulative population increase, if the cumulative income increase linearly, that means everybody have the equal distribution of the wealth. Otherwise, if it shows like this, it means not everybody has the equal wealth. In our statistics in this video, we use this Gini index to indicate if we have the same result. If the results are all the same, and then the Gini index will be 0. Okay, let's view the result. This is a decision tree built by Python with our data. You can see the final decision is not that easy to make. Okay, let me enlarge this graph. From the top, we can see the first condition is age. If the age is younger than 71.5 years old, and then we go to this direction. At this point, the Gini index is 0.129. That means we can't decide if all those people will survive or die. If we go to the left, then the second condition will be if the age is smaller or younger than 45.5. And then if we say true for the young people, and then we will have another condition. Say if the person has diabetes, if it's less than 0.5, means it's 0. In this example, I use 0 to indicate this person doesn't have diabetes. If it's 1, means this person has diabetes. So in this case, no diabetes, we come to this point. In this point, the Gini index is 0, means everyone is the same, and this means survive. There are 601 people in this group. They all survived, but the condition is they don't have diabetes, and also they must be younger than 45 years old. Okay, how about we go to the right? Now we came back to the first data point. If we go to the right, that means all the people to this direction are older than 71.5 years old. If all those people have diabetes, we go to the right, and then another condition, say if the person is older than 79.5 years old. Here, we hit another condition, say if the person is older than 97.5 years old. To this data point, we can see the Gini index is 0. That means everyone in this block, they are all the same. And here, say they all die. They couldn't survive. So you can see from this decision tree, it is very hard to figure out if a person will survive or die based on simple condition. So this is quite complicated decision tree. This is how I use decision tree and tried to figure out if a person will survive or die in coronavirus statistics. Please provide your comments and subscribe to my channel. Thank you so much for watching.